Hi everyone, and welcome back to another one of these videos. We're going through today mock set for paper 2H, so it is calculator paper. Okay, like I say, welcome back to the channel. If you enjoy these, like always, I say please like, and if you're interested in more of these videos, these walkthroughs, subscribe, because I'm going to keep uploading these until the GCSE exams this summer. Okay, without further ado, let's get started. Okay, first thing we need to do, divide 7,560 into the ratio 4 to 5. Now the way that I approach most ratio questions, unless they're problem solving ones, is with a kind of bar modelling or box style method. So 4 boxes for 4 parts, and then 5 boxes for 5 parts. Now my boxes here aren't exactly the same size, but I'm pretending that they are, just so that I put the same numbers in each. Okay, so we're pretending they're the same size. They're not exactly the same size. They're never going to be unless we measure them out, and that would be a complete waste of time. So yeah, just pretend they are the same size. So I've got 7,560, and I'm splitting that into 9 boxes. So divide that by 9. Okay, on my calculator, 7,560 divided by 9, 840. Now that's going to go into each box. Now that might be a little bit difficult to fill in because my boxes are so small, but obviously I just do my best. 840 in each, and then to the top part, 7,000 or 840 times by 4 is 3,360, and then 840 times by 5 is 4,200. Now just as a check, make sure they add up to our starting amount. They do, so that works. Okay, so 3,360 and 4,200, and it's got to be the smaller number first because it's 4 parts to 5 parts, so 3,360. Okay, question 2. A Venn diagram question. We've got it already filled in, I should say. The numbers are already fitted in. I was getting my sentences mixed up. So all of the members of X, so that's 1, 5, 3 and 15. 3 is in X, it's also in Y, it's in this overlap here. So 1, I'll put them in order, 1, 3, 5, 15. X intersection Y, so that's just going to be 3. X union Z, so this is in anything that is in X or it's in Z. So we've got 1, 3, 5, 1, 3, 5, 15, and then 9, 21. So 1, 3, 5, I'll do them in order, so 9, 15, 21. A number is chosen at random from the universal set, so that just means everything. Find the probability that this number is in Y union Z. Now we're doing probability here, so it's going to be a fraction. Y union Z, and we're choosing a number at random. So how many numbers are in Y or Z? So we've got 1, 2, 3, 4, 5, 6, 7, 8 that are in Y or Z. So union you can think of as or. How many was that again? 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 out of our total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 8 out of 11. Just double check that one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, 8 out of 11. Okay, next question. Question 3. Calculate the length of BC. BC is this length at the bottom here. Now we've got a right angled triangle, so I'm thinking either Pythagoras or trigonometry. As I've got 2 sides, I'm working out another side, it's going to be Pythagoras. So BC is equal to 16 squared minus, because we're working out a shorter side here, 6.7 squared, and then we've got to square root that to get our answer. And so we just type that into our calculator. If you're working out the hypotenuse, it's not subtract, it's add. 16 squared subtract 6.7 squared, and we give our answer to 1 decimal place, so it's 14.5 to 1 decimal place, and the units are centimetres. 14.5. Question 4. write this as an ordinary number. Now you can do this in different ways. As I've got the calculator, I'm going to use the calculator. 1.4 times by 10 power of 5 equals, gives me the answer there straight away. So 104,000. Write this in standard form. Well, that's going to be 6 times 10 to the negative 2. And just to check, type it in my calculator. Equals S to D. It's right. 6 times 10 to the negative 2. Things like that, which you can check on your calculator, make sure you do. 4.62 times by 10 to the power of 8 tins of beans were sold last year. These tins of beans cost a total of £300.3 million. Work out the average cost per tin of beans. Okay, so we need to do the total cost. 300.3 million, so that's 300 million. So this is going to be 300,000. 300 million, 300,000 divided by 4.62 times 10 to the 8, and we can just type that into our calculator. So fraction 300, 300, 000, so that's 300 million, 300,000 divided by 4.62 times by 10 to the power of 8, 0.65. Okay. Now this was in pounds, so that's going to be 0.65 pounds or 65p, which for a tin of beans makes sense. If you're getting 65 pounds for a tin of beans, you've probably gone wrong somewhere. So as a way of checking for that question, make sure that your amount makes sense in context, for the tin of beans. Okay, now next question. Becky buys a new car for £25,000. The value of this car will depreciate, that means goes down, by 20% at the end of the first year. So in terms of working that out, 25,000, if I'm going down by 20%, I think, well, 100 take away 20%, 100% take away 20% is 80%. That as a decimal is 0.8. So actually I want to find 0.8 of 25,000. And then 12% at the end of every year after the first year. So this is the first year, and it's going down by 12% every year after that. Now, for a depreciation, going down by 12%, 100 take away 12 is 88. Okay, and I would always suggest, actually, because it's a calculator paper, doing that on the calculator to make sure. Divide by 100 to get it into a decimal is 0.88. So times by 0.88 every year after that. Work out the value of the car at the end of 3 years. So first year, second year, and then we're going to times by another 0.88 for our third year. We could have just made that squared there, doesn't matter though. So we're going to type this into our calculator, and that will give us the answer. I'll put it where we can see it. 25,000 times by 0.8 times by 0.88 times by 0.88. £15,488. There we go. Moving on to question 6. The diagram shows a shape made from a trapezium ABCD and a semicircle with diameter DC. Now, first thing to notice is if that's the diameter is 8 and the radius has to be 4, just because I might need that in a second if we're doing area. DC equals 8. The shape has, so the total shape has area 64 centimeters squared. The height of the trapezium is 5 centimeters. Work out the length of AB. So what we can definitely work out is the area of the semicircle. So area of semicircle is a half of pi r squared. So pi times by 4 squared. The reason it's a half is because it's half a circle, and the area of a circle is pi r squared. Pi times by 4 squared is 16 pi, and half of that will be 8 pi. So this is 8 pi here. Units would have been centimeters squared, but it doesn't matter at this point. Area of trapezium is the area of the full thing, so the shape as area is 64, subtract 8 pi. Okay, Now that's going to give me a decimal answer. At the minute I'll leave it like that. Okay, so that would be the area of the trapezium, 64, which is the total, minus that 8 pi. Now, to work out the area of a trapezium, it's half the sum of the parallel sides, so 8 add AB, okay, times by a half, times by 5. That's got to give me 64 minus 8 pi. Okay, you've got to give our answer correct to one decimal place. So let's write that out. 64 minus 8 pi is equal to a half of AB plus 8 times by 5. And essentially now what we need to do is solve this equation until we get to AB. So what we can do is a half times by 5 is 2.5. AB plus 8, that's still equal to 64 minus 8 pi. Divide by 2.5 on both sides. So divide by 2.5 on both sides, because this is 2.5 times by AB plus 8. And we're going to have to do this bit on our calculator now. So fraction button, 64 minus 8 pi divided by 2.5 gives us this decimal, so 15.5469 dot dot dot. That's equal to AB plus 8. And the last step is to take away 8 from both sides. Okay, so keep that number on our calculator and then take away 8, and that's our answer. So AB is equal to one decimal place, which is what we want, 7.5 centimetres to 1 dp. And just as a way of checking, if we now work this through, so we put on 7.5 here and work this through, so a half times by 7.5 plus 8. It won't be exact because I've rounded this here obviously, but as long as we can get it very very close, and then it'll be fine. Half of this times by 5, half the sum of my parallel sides times the height between them, gives me the area of that. And then I want to add on a half of pi times by 4 squared, pi r squared, and this should give me something very very close to 64. It does. Okay, so there we go. Okay, question 7. On Monday, 4 bricklayers took 3 hours to lay a total of 4,200 bricks. On Tuesday, there were only 2 bricklayers. Work out how many hours it would take 2 bricklayers to lay a total of 3,150 bricks. Okay, now this question is kind of, well, it's indirect and direct proportion at the same time. Excuse me. So 4 bricklayers is 3 hours for 4,200 bricks. Now we are going down to 2 bricklayers. So 2 bricklayers. Now obviously the fewer people you've got, the longer it's going to take you. So that is dividing by 2. So it would take, got a times by 2 here, just do it underneath because I've run out of room at the side, 6 hours. If we halve the number of people, it's going to take double the amount of time. So 6 hours for 4,200 bricks. Okay. Now we've definitely got 2 bricklayers, okay, and we need to get now from 4,200 bricks in 6 hours to 3,150. So now I'm going to separate off, and I'm going to start a new kind of, well, some new working out, if that makes sense, because now I'm going to go from indirect proportion to direct proportion, because now we're not changing the number of bricklayers. The number of bricks to the number of hours is in direct proportion. If I reduce the number of hours, I'll be able to, or these bricklayers will be able to lay fewer bricks. Okay, so now as 1 increases, the number of bricks increases, it's going to take longer, so they're in direct proportion. As 1 increases, the other increases. Okay, so 6 hours 4,200 bricks. Now I need to get to 3,150, so 3,150 bricks. Before I can get there though, I might need to do 2 steps. So I'm going to go to 1 brick, and that's going to get me into, you know, some decimal amount of hours, which is absolutely fine at this point. So divide by 4,200 and then times by 3,150, and it's going to be the same on the other side. Divide by 4,200 and then from my answer there, times by 3,150. Don't worry that it's going to get you a horrible decimal amount of hours, because it doesn't matter until we get to our answer here. 6 divided by 4,200. We get, I'm just going to put it as 1/700 hours. And then I'm going to times that by 3,150, and we get 4.5 hours. There we go, I told you it'd work out fine. So 4.5 hours. So this first bit was indirect proportion, or inverse proportion, I suppose. As one thing decreases, so as the number of bricklayers decreases, that means it's actually going to take longer, so the other thing is going to increase. That's inverse proportion. Then direct here, as one thing decreases, the other decreases. As one thing increases, the other increases. Okay. Next question, question 8. Simon invested an amount of money in a savings account of 0.5% per annum. That means per year, compound interest. That bit's important as well. At the end of 3 years, the amount of money in the savings account was £12,180.90. Work out how much money Simon invested in the savings account. Okay, so we've got something, the original amount, times by, if it's going up by 0.5%, what is the multiplier going to be? Well, it's 100 add 0.5 and then divide that by 100. So the multiplier is 1.005, and he invested that for 3 years. So to the power of 3 is equal to £12,180.90. Okay, so once you've got that set up, really, all we have to do is rearrange this and divide both sides by 1.005 cubed. Divide by 1.005 cubed. Now that will cancel out, and so we'll just get our answer here, the original amount. Struggling to spell. Original is equal to £12,180.90 divided by 1.005 cubed. So again, on the calculator, £12,180.90 divided by, I probably should have done this as a fraction, shouldn't I? 1.005 cubed. And we get 11,999.998. Now if we round that to 2 decimal places, which we should do because it's money, then actually what we're going to get is, well, those will all go up, this 9 will go up to a 10, and we should get 12,000. Okay, 12,000 to 2 decimal places. Okay, that 8 makes the 9 go up, carry 1, 9 goes up, and so on. That 9 goes up to a 10, carry 1 over, 12,000. Now again, just to check, start off with my original, 12,000 times by 1.005 cubed equals 12,180.90. There we go. Okay, next question. Question 9. PR and PS are 2 sides of a square, so that means that's a right angle, 90 degrees. PS and PT are 2 sides of a regular pentagon. Okay, so PS and PT. So that means that this angle I can work out. I know it's 108 from memory, but I can work it out. Now the way to work it out is by doing number of sides. Pentagon's got 5 sides, so you've got to basically use m minus 2 times 180, and that gives you the total divided by n. Okay, now I wouldn't remember that formula really, other than this n minus 2 bit. So essentially, the number of sides a shape has got, you can fit 2 fewer triangles in. So a pentagon's got 5 sides, so actually you can fit 3 triangles into it. Now if you can fit 3 triangles into it, a triangle is 180 degrees, that means the total amount of degrees, or the sum of the degrees in the shape, the sum of the angles, will be 3 lots of 180. 3 times 180 is 540. Now that's the total of the angles. In a pentagon there are 5 angles. So 540 divided by 5 will give us one of the angles, which is 108. So 108 degrees is one of the interior angles of a pentagon. Now that means we can then work out this angle here. Okay, right, so 360, take away 90, take away 108. 360, take away 90, take away 108. Gives us 162. Now that is the interior angle of one of these shapes. Now there's a couple of ways you go about this. You could kind of set this formula that I wrote up here, or this, yeah. You could set this equal to 162 and rearrange it. You could also work out the exterior angle. So 180 take away this and then just divide it by 360, because the sum of the exterior angles adds up to 360. And actually the exterior angle method is probably simpler and quicker than rearranging or making an equation and solving it using this. So I am actually going to work out an exterior angle. To do that I'm going to use a ruler. An exterior angle, to do that I need to basically extend one of the lines, or one of the sides of the shape. So I'm going to extend this line here like that. Okay, now this exterior angle here has got to be 180 minus 162. So that's going to give me, or should give me, 18. Yeah. And again, like I did there, just check those little things with your calculator, because obviously you're doing a calculator assessment, you've got it there with you. What you don't want to make is any kind of calculation errors that, you know, usually you wouldn't make, but because you're under pressure, you do overthink things. Okay, you don't want to lose 1, 2, maybe more marks because of a relatively simple mistake. Okay, now that's the exterior angle. Now, like I said, the total of all the exterior angles of a shape add up to 360. So if we do 360 divided by 18, we will get the number of sides, because the number of angles is the same as the number of sides for a polygon. 360 divided by 18 is 20, so we've got 20 sides. N is 20. And just to check, we can use this formula again. So 20 minus 2, so 18, times by 180, divided by 20, 162. Okay, there you go, so it does work. But this exterior angle method, okay, is a lot more straightforward. Okay, moving on. Question 10. Solve these simultaneous equations. Now, the first thing to mention is actually, before I even do this, on this calculator, the FX991EX, which you are allowed in GCSE exams, if you go down, there's an equation function here, and you can plug in simultaneous equations, 2 unknowns. Okay, so x is, well, 2 is out the front of the x, 3 is out the front of the y, equal to 6. 7x, and then minus 2, y, and then 1. Okay, I'm not going to solve that just yet, and I'll wait till I've done it, and then I'll show you that we get the same answer. But this you can use to check on your calculator, so you will know once you've done this question whether you've got it right or wrong, and whether you need to spend more time on it. Okay, let's do it. So first thing I need to do is label the equations. So I'll call this equation 1, equation 2. Now I need to make it so I've got the same numbers in front of my x's or in front of my y's. So because it's 3 and 2 in front of the y, I'm going to go with those. So I'm going to do equation 1 times by 2. That's going to give me 4x plus 6y is equal to 12. You've got to multiply every number by 2. an equation 2 times by, and then I want to make this into 6 as well, so I'm going to go times by 3. So 7 times by 3 is 21x minus 6y. 1 times by 3 is 3. So now I've got two new equations, equation 3 and equation 4. Okay, from there you can see this is plus 6y and this is subtract 6y. So I'm going to add the two equations together, because if I have 6 add a negative 6, that will cancel out. So equation 3 add equation 4. So 4x add 21x is 25x. These will cancel, and 12 add 3 is 15. So we now divide both sides by 25, excuse me. Divide both sides by 25, and what we get is x is equal to 15 over 25, and I can simplify that, divide top and bottom by 5, I'm going to get 3 over 5, which is 0.6. Okay, right, so that's my first answer. Now what I need to do is substitute x is equal to 3/5 into one of my equations. So substitute x is equal to 3/5, and then I need to choose one of them, usually the one with the lower coefficients, smaller coefficients, so this first one here. Smaller coefficients being the numbers before your letters. Okay, so sub x equals to 3/5 into equation 1. But to be honest with you, you can't go wrong substituting it into any of the equations, okay, because they should all be true as long as you've multiplied these correctly. However, just to make sure and to reduce any potential for errors, I wouldn't substitute it into equations you've multiplied by, just in case you have made any mistakes. Use one of the originals. Okay, so 2 lots of 3/5 plus 3y is equal to 6. So 2 lots of 3/5, so that is going to be 2 times 3 is 6/5, so we've got 6/5 plus 3y is equal to 6. Take away 6/5 from both sides. Okay, I have to do this bit without my calculator because it's on the solving part. 3y is equal to, now 6 in terms of fifths is going to be, well, 6 times 5 is 30. It's 30 over 5. 30 take away 6 is 24 over 5. And then divide both sides here by 3. And what I basically need to do here, and if you can do, like in this case I can, nice and easily, 24 divided by 3 is 8. So I can just divide the numerator here. I don't need to do any kind of other manipulation with my division there. Obviously you do use your calculator anyway, so your calculator does it for you. 24 divided by 3 is 8 over 5. Okay, so we've got 3/5 and 8/5. Okay, and again we could write 8/5 in terms of, well, that's 1 and 3/5, so that is going to be 1.6. You can write them as fractions though, so x is 3/5 or 0.6 and y is 8/5. Okay, let's now get the calculator, press equals and check. So the first one it will come up with, I'm trying to get the right lighting, is the x one, so that should be 3/5 hopefully, if I've done this right. Yep, there we go. And then y is 8/5. There we go. So you can check your answers there on this calculator. I would recommend, if you haven't already got it, getting one of these for your GCSE, because it has other functions as well, such as the inequality functions if we need it. It's got some ratio functions here. It has got also some statistics, although you won't really use that, but it's got essentially the most important ones are the equation ones, simultaneous equations, and solving polynomials. So quadratics, you can solve those. Okay, so things like that, which will just help to check. And also, if you're thinking about going on to A level, you will need this calculator at A level. So if you're going to get it, if you're going to do A level, you might as well get this, because you're going to use it later on anyway. You're going to need it later on, so you might as well buy it and then use it for your GCSE as well. Okay. Right, next question, question 11. Okay, the incomplete table and the incomplete box plot give information about the number of lorries using a bridge each day last January. Okay, we've got to fill in these values, and so we can just read them off of here. So 200 is the medium, Okay, I use the information in the table to complete the box plot. We need to do that first of all. I was already completing the table. I might as well carry on at this point, but it's part 2 of A. Lower quartile is, so that's 150, 60, 70. 170 is the lower quartile, that's this lower end of the box, and the lowest value is 20. Okay, now to complete this, we need to put on the upper quartile, which is 280. So that's 250, 60, 70, 80. So it's going to go here, it's going to go 4 squares high. Okay, so that's the upper quartile, and the greatest number is 405. Now each of these are 10, so I'm going to have to go in between here. It's going to make my life a little bit difficult. So go here, and then we need to go 4 squares up. Okay, there we go. So join the box up, and then got to join up the whisker. Okay, there we go. We've done the table and we've done the box plot. Okay. Next part is usually comparisons. Okay, so we need to compare this box plot, the one we've just done, with another one. Just trying to make this fold a little bit better so it's easier to see on the screen. Okay, box plot below gives information about the number of lorries using the bridge each day last February. Now if we go back, I expect this one will be different. It's January. So we've got January and we've got February. Compare the distribution of the number of lorries using the bridge last January and the distribution of the number of lorries using the bridge last February. Okay, now there's a couple of key things here we want to look at. We want to look at the median. Okay, so the median is the is an average. So on average, let me write that again. Average. There were more buses, so not buses, lorries crossing the bridge in, well, February's 250 and January is 200. In February, as the median is 250 compared to 200 in January. We also want to talk about either the range or the interquartile range. Okay. So if we have a look, let's go with the range. So the range on here goes from 370. So 370 subtract. We've got here 130. Okay, 370 minus 130 is 240. So the range for February is 240. Let's have a look at the range for January. So we've got 405 take away 20. 405 take away 20 is 385. So 385 for January, 240 for February. So it asks compare distribution. Okay, now what we also need to say is about the range. The range talks about the spread of the data. So we could talk about there is more variation in the weights of the lorries crossing the bridge in January because the range is bigger. Okay, so there is larger variation, not of the weight, sorry, of the number of lorries crossing the bridge in January than February, as there is a range of 385 compared to 240. Okay, so actually the data is more spread apart, less consistent, and allows you essentially to less reliably predict how many lorries would be crossing that bridge in January than in February. It's easier to predict in February because actually the data is closer together. Okay, so yeah, you want to speak about two key things: the mean and the range, or mean and interquartile range, because range and interquartile range are both they both represent the spread of the data. Okay, and then the only average you've got from here is the median, so it has to be the median. Okay, next question. Right, question 12. Work out the size of angle AHD. Give your answer correct to one decimal place. Okay, now first thing we need to work out is what is AHD is this one. So we've got a right angled triangle, which I'll sketch out now, that goes from A, H, D, and we need to work that out. So at the moment, we don't have any pieces of information. Okay. Now what we can work out straight away is we can work out the base here, and we need to work out the size of the angle. Okay, so EH is 15. Give your answer correct to one decimal place. Okay, we have got some other angles here which aren't on. Angle EDH. So E to D to H. So this angle is 64. Okay, that could help us. Angle A to C to D. So this angle is 28. Okay. And we've also got 15 at the back here for that side. So we've got two other triangles now. We've got, I'll do this back one, ADC. So ADC, and we've got 28 in here, and we've got 15 along the bottom. Now what would be useful, if we can work out AD, we can then put it onto this triangle here. So using trigonometry, we've got opposite and adjacent. Right, so opposite and adjacent, if we remember SOH, CA, TOA, opposite and adjacent is going to be tan. So tan 28 is equal to opposite, which is AD, over 15. Okay, now rearranging that, we need to multiply here both sides by 15. So we get 15 tan 28 is equal to AD. Now I could work that out and I'll get a decimal, so I don't want to work that out just yet. I want to leave that in an exact form, so like that. So AD is 15 tan 28, so I'll just write that on here, 15 tan 28. Okay, keep that in an exact form so you don't get a rounding error. Next thing we need is DH. Now I can work that out by again drawing another triangle. So DH, so I've got 64 degrees up here, so this is DEH, right angle in here, that's 64 degrees, and then we've got 15 again here. So we need to work out now the hypotenuse and we've got the opposite because it's opposite the angle. Okay, so opposite and hypotenuse, that's sine. So sine of 64 is equal to 15 over dh, opposite over hypotenuse. Okay, so now we need to basically multiply through by dh, and we get dh times by sine 64 is equal to 15, and then we need to divide both sides by sine 64. Divide by sine 64. So, and again we'll leave this in an exact form, dh is equal to 15 over sine 64. So dh, we can put it here, we'll put it in both places, 15 over sine 64. dh is 15 over sine 64. Okay. Right, and the last thing we need to do actually is work out this angle. Now we've got the opposite and we've got the adjacent. Move it there so you can see it a bit better. We've got the opposite and the adjacent. Opposite and adjacent is tan. So we'll call this angle, let's call it x, just keep things simple. So tan of x is equal to opposite, so 15 tan 28 over, and then we've got another fraction on the bottom, 15 over sine 64. So we type that into our calculator, and then what we need to do actually is inverse tan our answer. So we'll do that first of all. So tan of x is equal to, and you can put a fraction within a fraction, there's nothing, absolutely nothing wrong with that. So again, where you can see it, 15 tan 28 on the top. Now make sure it's got the d at the top of your calculator because that stands for degrees. If it's not, any trig functions you do will come out wrong in terms of the answers. Over, now on the denominator make another fraction, 15 over sine 64. And that gives us this decimal, okay? Keep that on your calculator, 0.47 dot dot dot. So inverse tan minus 1, 0.47 dot dot dot, gives me, so now I need to shift and inverse tan, and then answer, and then equals, I need 25.5, I need it to one decimal place, 25.5. 1 dp. Okay. That was a tricky question, that one. There's a lot in it that you've got to work out. It's a little bit surprising actually that it's only 4 marks because you've got to do trig three times really. Okay, there's inverse trig there as well, there's sine, there's tan, there's, you know, both ways of manipulating these equations. Well, in fact all the ways. You've got to multiply here, you've got to basically multiply and then divide, and then this one you've got to inverse tan of a decimal. Okay, question 13. 6 to the power of negative 2 to the power of something is 6 to the power of 8. So 6 to the power of negative 2 to the power of w, index laws means that is negative 2w is equal to 6 to the 8. So that means negative 2w is equal to 8. So that means that w is equal to negative 4. Okay. Show that this can be written in the form a to the m. So again, index laws. Top bit is a to the power of 2r divided by a to the power of 3t. And when you divide, you subtract your powers. Okay, oh, it's a u, sorry, not an n. So we get a to the power of 2r minus 3t. Okay, so u is equal to 2r minus 3t. Okay, next question. Given that n to the power of 2/3 is 8, and n is greater than 0, work out the value of n. Give your answer in form a root b. So n to the power of 2/3 is equal to 8. The way I would approach this question is essentially we want to end up with n to the power of 1. Okay, because n to the power of 1 is just n, and that will give us our answer. So what we could do is, by using this law they want us to use above, let's basically put both sides to the power of, what do I times by 2/3 to get 1? Well, it's going to be 3/2. 3 times 2 is 6, 2 times 3 is 6, 6/6 is 1. Okay, so I need to put both sides to the power of 3/2, and that will do it in one step essentially. Okay, and we can just type that into our calculator. So 8 to the power of 3/2. Okay, it's not going to give us an exact answer in terms of a surd form, so actually we're going to have to do this ourselves. So that the denominator of the power gives you the root, so it's going to be square root of 8. So square root of 8 and then cubed. Square root of 8, if you do that on your calculator, it gives us 2√2. Try and get the best place to see this. 2√2. So actually we've got 2√2 cubed. And you could try and type that into your calculator. Sometimes it does it in the exact form, sometimes it doesn't. It does here, 16√2. Okay, so we get 16√2. The reason that works is you've got 2 cubed, which is 8, and then √2 times √2 times √2 gives you 2√2. So 8 times 2√2 is 16√2. There we go. Next question, 14. Okay, there are some flowers in a shop. Each flower is either red or yellow. Each flower is a tulip or a rose. For these flowers, number of tulips, number of roses is 6 to 5. Number of red tulips, number of yellow tulips is 3 to 4. What proportion of the flowers that are, work out, sorry, the proportion of the flowers that are red tulips. Okay. Now this question isn't as difficult as it seems at first glance. Now essentially, the way to do this is with fractions, and fractions of amounts essentially. Convert these to fractions. So number of tulips, the number of roses. So 6 out of 11 and 5 out of 11. So number of tulips is 6 out of 11. Okay, so 6/11 of the flowers are tulips. Right, just think about how we lay this out. So let's just write it out in words. So 6/11 of the flowers are tulips. Number of red tulips and number of yellow tulips is 3 to 4. Work out the proportion of the flowers that are red we need. So red tulips is 3, that's 3 out of 7, 4 out of 7. We need red tulips though, so we need this 3 out of 7. So what we need to do is we need 3/7 of 6/11. So 3/7 of the tulips are red. So essentially 3/7 of 6/11. To do that, you do 6/11. Usually with of, that means times in maths. So 6/11 times by 3/7 will give us the answer. And that's it. It's a lot more straightforward than it seems at first glance. So 18/77. Okay, next question. Alison has some shapes. Okay, she has 14 red cubes and 10 red spheres. She has 12 black cubes and 8 black spheres. Alison is going to select 2 of these shapes. Of these 2 shapes, only one can be red, only one can be black, only one can be a cube, and only one can be a sphere. In how many ways can Alison select the 2 shapes? Okay. So, "14 red cubes, 10 red spheres." What I want to do to start off with is actually work out the total. So 14 add 12, how many cubes have we got in total? 26 cubes in total. How many spheres have we got in total? 18 spheres in total. Just going to select 2 of these shapes. of these two shapes, only one can be red, only one can be black, only one can be a cube, only one can be a sphere. So essentially we want a red cube, so red cube, and then we would have to have a black sphere, and then we could have a red sphere and a black cube, and then we would want, and this question is only 2 marks as well, so bear that in mind. It's not asking for probability, just asking about in how many ways. So red sphere, black cube, and then does the order matter? That's what we've got to think as well. I don't think the order does matter. Okay, in how many ways can Alison select the 2 shapes? Okay, so selecting 2 of these shapes, of these 2 shapes, only one can be red, only one can be black. So it has to be a red and a black one, only one can be a cube, and only one can be a sphere. Okay, so there are 2 ways. It's just about this repetition part, and it's just actually thinking about the question and how it's worded. You've got to think very carefully about how the question is worded, as well as not taking too long about it. So you're going to take 2 of these shapes. Okay, of these 2 shapes, yep. In how many ways can Alison select the 2 shapes? How many ways can she select the 2 shapes? So selecting, that word select, she's selecting one, then she's selecting another one. Actually, I do think the order could matter here. Okay, so we're going to do it the other way around as well. So black cube, red sphere, and then black sphere, red cube. So they're the different ways. And if, let's say, they're asking about how many different ways can she select the 2 shapes, there are different options. So then we've got to think about, well, a red cube, there's 14 of them, okay, times by black sphere, there's 8 of them, okay. Then we've got a red sphere, okay, so there's 10 of those, times by a black cube, which is 12. Then we've got the same thing again, essentially, so this doubled, so black cube, which is 12, times by red sphere, which is 10, okay, black sphere, which is 8 times by 14. Right, so we're going to work those out definitely, and then it's just about that repetition. 14 times by 8 is 112, 10 times 12 is 120, and then we're going to have 120 again and 112. I think because of that word select, that the order is going to be important, and how many ways can Alison select the 2 shapes. I think it's going to be the total of all of these. Okay, you're not discounting the other ways around. So 112, add 120, add 120, add 112, 464. Okay, and that is based on the fact that it's the word here, select, because she could select a black cube first and then a red sphere, and that is different in her selection, the way she selected them, to a red sphere and then a black cube. Okay, that is a difference in the way that's been selected. Okay, next question, and actually before I move on to the next question, I must say that is conceptually harder to think about, I would say, for 2 marks than the last question was for 3. Okay, now on the mark scheme it does actually say that it should be, you shouldn't be counting these as different things. Now, reading the question, it doesn't give any indication of that, and actually I would disagree with either the way this question is worded or with the mark scheme, to be honest with you. I don't think this is, you know, one of them is, I don't think is right. This isn't how many ways can Alison select the 2 shapes. Now, if you select a red cube first, or a black sphere first, that is different to selecting it the other way round. Okay, a red cube is different to selecting that first to a black sphere first. That is a different selection. Okay, if you were to do it in a tree diagram, it is different. It's a different way. Okay, they're not different shapes. You don't end up with a different outcome. Okay, but that's not what the question says. It says, in how many ways can Alison select the two shapes? So with the way that question is worded, it should be 464, which is why I disagree with the mark scheme, which says 232. The answer on the mark scheme is 232. They haven't counted these duplicates here, but that's not clear from this question whatsoever. Okay, so strictly speaking, these are counted as the same, so we need to do 464 divided by 2 to give us 232. Okay, so it's not 464, it's 232, but like I say, the mark scheme doesn't make that clear, and actually by the wording of the question, I disagree. It should be 464, because the selection is different, and that is a different way of selecting the two shapes. Okay, but yes, with this question, divide by 2, and that's always the problem. Do you count the duplicates with these types of questions, or don't you? Okay, and I think in terms of somebody that's setting the questions, you've got a duty to the people that are completing them to lay them out in a way which does not leave that in question, like this question has done. Are you counting the other ways round or not? Does the order matter or doesn't it? You've got to be very clear with that, because it's very obvious once that is clear which way it would work and how it would work. Okay, but in how many ways can Alison select the two shapes, that suggests that the way that she selects them is important. Okay, right, next question. Right, the graph of y is equal to x squared is reflected in the line with equation y is equal to x. Now what I would suggest doing here is getting a pencil and a ruler for graph questions. Y is equal to x is going to be approximately like this, and then if you use a ruler and a pencil you can rub your work out afterwards. That's approximately line y equals x. Okay, it's a reflection, or it's basically diagonal. The graph of y equals x squared is reflected in the line y equals x to give the curve C. So if we sketch the curve, y equals x squared, it's going to look something like this. Okay, now if we reflect that, we are going to basically get the inverse of y equals x squared, which is going to be square root of x. Okay, so essentially what you might want to do at this point, because it's going to go, it's going to be a square root this way, I'm going to rotate my page. Okay, and then what I can do is I can just do my square root again. Okay, should go through here, and then it will curve around because it's a reflection, go down through here, and then back up the other side. If you do it in pencil, if it does go wrong, you can correct it. Now I am, because I've done it in pencil, going to try and rub out, to the best of this rubber's ability, that other line, because that was just to help me, that was just a sketch to help me. All we wanted was the line that I've just drawn, the reflection. Okay, that's pretty good. There's nothing wrong with obviously having that rubbed out, it's just so that they can see, well, it helps the marker see as well what you've done to find it. Sketch the graph of y equals x squared. Oh, I've just rubbed it out. Sketch the graph of y equals x squared and the curve C. Okay, draw it again. My mistake. No, I didn't think I had to draw it. So that is y equals x squared. I can basically follow my rubbed out line here. Okay, there we go. Clearly label the graph. So that's y equals x squared, and this is the graph of C. We know it's the graph of the square root of x, positive and minus, because you've got both halves of it. Yeah, it's the square root of x. It's the inverse. It's reflected in the line y equals x. B. Here are 7 graphs. Graph A, B, C, D, E, F, and G. Complete the table below with a letter of the graph that could represent each given equation. So 3 to the x, that's an exponential curve, so that's going to be A. Tan of x, that's a repeating function with asymptotes in, I know that, so that's going to be D. X cubed, that's a cubic graph, plus 2, so that tells me where it goes through my y-axis, so it's positive, so it's going to be graph G. And then 3 over x is a reciprocal curve, so it's going to look like graph E. Okay. Graph B would be 3 to the power of, well, it would be 3. It's kind of an exponential decay, so I think 3 to the power of negative x, 3 to the power of negative x would do this, and then C would be a straight line, so y equals 5x, something like that. Okay, next question. 17. The number of moose in Alaska at the start of the year n is P n. The number of moose in Alaska at the start of the following year is given by this. Okay, where G is a constant. At the beginning of 2015, there were 200,000 moose in Alaska. At the beginning of 2016, there were 200,720 moose in Alaska. Work out how many more there were in Alaska at the beginning of 2017. Work out how many moose, not how many more, how many moose there were in Alaska at the beginning of 2017. Right, so first thing we're going to do is set this up as an equation. So if I plug in 200,000 where Pn is, that's going to be equal to 200,720. 200,720, because Pn plus 1 gives me the next year. 1.04 Pn, so 200,000 minus this G, this constant G. So divide both sides by 1.04. Okay, so on my calculator, 200,000, that's 20,000, divided by 1.04, we get this number here, which isn't particularly nice. So, oh sorry, 720, that's where I've gone wrong. There we go, 193,000, so 193,000 is equal to 200,000, subtract something, and you can probably see at this point it is going to be 7,000. If you're not sure though, we'll just follow the whole process through. So add G to both sides. 193,000 add G is equal to 200,000, and then take away 193,000 from both sides. And we get that G is equal to, again, check this on your calculator, don't want to make any silly mistakes, 7,000. Okay, now that's not the answer just yet, because we now need the moose in 2017. So we've got 2016, so what we're going to do is we're basically going to plug 2016 into this iterative formula here. Now we know what G is. So the population, which is what I expect P stands for, in 2017 is going to be 1.04 times by the population in 2016, which is 200,720, subtract G, subtract 7,000. Okay, and that will give us our answer. So we just type that into our calculator. 1.04 times by 2 brackets 200,720 minus 7,000, close bracket, equals S to D 201,468.8. We're going to have to round that, so 201,468.8, which is approximately 201,469. 201,469. Now I expect on the mark scheme here they'll give you either way. They'll give you 201,468 or 201,469, because actually this is an approximate value, and so it's closer to 469 than 468. So they would allow that, but equally it's not a whole number of moose. So it's 0.8, so they would accept rounding it down as well. So I'll go with 201,469. What you would want to check though with something like that is if you do get a strange number like that, just double check it. So double check my working out here. 7,000 confident is right. 200,720, yeah, that's in my calculator, right. And 1.04, yeah. Okay, so I am confident that's right. Next question, question 18. Let's check quickly how many questions we've got. So 19, 20 and 21. Okay, solve this inequality. First thing we want to do is actually think about or do a sketch of this. So I don't know where my solutions are yet, I'm just doing a sketch. I want where it's less than 0, so actually I want in between 2 points, because I want where this x squared curve is below, less than 0, so below the axis. So I want between those two solutions. Now I just need to find them. Right, now what I would suggest, instead of trying to factorise this on a calculator paper, unless you can see it quickly, so, you know, 2x, 3, 1, 3 and minus 1, actually that would work. I could see it quickly. If you can't, use the quadratic formula, which is what I'm going to use. So, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So, b is 1, a is 2, c is negative 3. Minus 1 plus or minus square root of 1 squared minus 4 times by 2 times by negative 3. All divided by 2 times by a, which is 2. So x is equal to this. X, okay. Okay. Right, now type this in. So minus 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 3, all divided by 2 times 2, and we get x is 1, or x is, change this now to a minus, negative 3 over 2. Negative 1.5 are solutions of 2x squared plus x minus 3 is equal to 0. So they're my 2 points actually, 1 and negative 1.5. Obviously I haven't drawn this the way it should look. Actually this should be further away from my y-axis than this, but it was a sketch at the beginning. I had no idea where these points were, and actually it's not important. All that was important is knowing that it's going to be between those two. So for 2x squared plus x minus 3 less than 0, x is less than, if it's less than 0 it can't be equal to them, so it's less than 1 and it's greater than minus 1.5. Okay, and now what we need to do is just show that on this number line here. So negative 1.5 is in between negative 1 and negative 2, so I'm going to do a circle there, and then 1 is just on 1. So we're going to put a circle there, and then we're going to join them up. Okay. Don't fill them in because they can't be equal to them. And again, just to double check that, on this calculator, menu, down to equation, press equals, polynomial, degree of polynomial is 2, and then we can just type in 2 for x squared, 1 for x, and then minus 3, and it will give us these solutions. So we can check this way, x is 1, or x is negative 3 over 2, negative 1.5. So you can use that to check. Okay. Question 19. Okay. OA is A, OB is the vector B, P is the point on AB such that A to P is 3 to 2. Now I would write that as 3/5 and 2/5. That will help us later on. Find O to P in terms of A and B. Now first thing we need to do is actually, before we work out 3/5 of this line or this vector, we need to work out the vector. So A to B is minus A plus B. Minus A plus B. Okay. So O to P is O to A plus 3/5 of, so O to A plus 3/5 of A to B. Okay, so that is O to A is A plus 3/5 of A to B, which is minus A plus B. So that gives us A minus 3/5 of A plus 3/5 of B, and just like before, use your calculator. 1 take away 3/5. Don't make a mistake on something relatively simple like that. 1 take away 3/5, okay, is 2/5. Okay, so we've got 2/5 of A plus 3/5 of B. Now it says give your answer in the simplest form. I would argue that is, however, what you can do is factorise out a fifth. 2A plus 3B. Okay, because a fifth times 2 is 2/5, a fifth times 3 is 3/5. So a fifth of 2A plus 3B. And again, for a question later in the paper, that's relatively straightforward. Okay, next question. Nearly there. Question 20. Show that f of x is x. So this is f of x. So you take your f of x function and you put it back in to f of x. So replace the x with the whole function, if that makes sense. So we're putting this function where x is. I'll show you exactly what that means. So we've got 1 minus, now instead of writing x, we're going to write this whole thing. So 1 minus x over 1 plus x. Okay, so we're replacing x with the whole function over 1 plus 1 minus x over 1 plus x. Okay, now we've got to show that that's equal to x. There's two different ways to do this. Essentially, the denominators of this fraction on the numerator and the fraction in the denominator are 1 plus x. So what I would suggest actually is times top and bottom by 1 plus x, because you want to get rid of any denominators. You want to get rid of any fractions within fractions. So let's do that first of all. So 1 times by 1 plus x, so that's going to be 1 plus x, minus this fraction times 1 plus x is just going to be 1 minus x on the top. So we're subtracting here 1 minus x. Put it in brackets to make sure that you actually subtract the 1 and you subtract this, subtract x. Okay, and then on the bottom, 1 times by 1 plus x is 1 plus x, plus 1 minus x. Okay, right, now we've got 1 plus x minus 1 plus x. Okay, that should be x there. And then we've got 1 add 1 is 2. Actually, I'll just write this out as the same thing as before. Then we've got 1 and minus 1 is 0. X add x is 2x over 1 add 1 is 2. And we've got x minus x, so that's going to cancel. So that gives us 2x over 2, which is just x. There you go. That was a bit of a tricky substitution because of the way they've done this and also manipulating these fractions here. Okay. It then says hence, which means basically you can pretty much use what you've done from the last question. Write down the inverse function. Okay. Now if I put x into f of x, or if I've got a function, so let's call it g of x, if I do g negative 1 of g of x, that will basically undo what the function did, and so I'll just get out x again. Okay, so in the same way, f negative 1, or the inverse function of f of x, should give me back out what I started with. Okay, so if I put some number into my function, let's say I put 2 in, I get out 5. If I then put that 5 into the inverse function, I'll get back to 2. So I put x in to f, and then put my answer into the inverse, I'll get back my original. Okay, so you can see now this inverse function must be f. They're the inverse already. So f of x is the inverse function, which is 1 minus x over 1 plus x. Okay, and it's only 1 mark and it's a hence, so you shouldn't really have to do any work for it. Okay, last question. There are only red counters, yellow counters and blue counters in a bag. Kevin takes at random a counter from the bag. He puts the counter back in the bag, so we're replacing it. Lefner takes at random a counter from the bag. She puts the counter back in the bag, again replacing it. The probability that both counters are red or that both counters are yellow is 13 out of 36. The probability that the first counter is red and the second counter is not red is a quarter. Seb takes at random a counter from the bag. Work out the probability that Seb takes a yellow counter. You must show where you're working. So what this is basically asking us for is to find out the probability that something is yellow, that the counter is yellow. So actually we need to work out all of these probabilities using what they've given us here. We're going to use a tree diagram. But this is going to have replacement in it. We're going to have X's probably and Y's or something like that. Well, no, not X's and Y's, you don't need that. Right, red, yellow and blue counters in a bag. Okay, we're going to need a third option here, which I've missed off. So, I'll do that a bit smaller. So let's call this red, yellow, blue. Red, yellow, blue, red, yellow, blue, red, yellow, blue. Okay. Kevin takes that random a counter from the bag. He puts the counter back in the bag. Okay. Lefner takes a counter from the bag. She puts the counter back in the bag. Right, let's say there's A, red counters, B, yellow counters, C, blue counters. Okay. So we've got Kevin, this is Kevin, taking a counter out of the bag. He puts it back in, and this is Lefner taking a counter from the bag. Probably that both counters are red or that both counters are yellow. Okay, it's 13 over 36. So we need to start filling this in, I suppose. A over A plus B plus C, and then A over A plus B plus C, and so on. So we've got red, red. Whether that both are red or that both are yellow. Yellow is going to be B over A plus B plus C, and then B over A plus B plus C. Okay, so multiply those together and add them together. So we've got it's not going to be particularly nice. A over A plus B plus C squared is that probability, and then for both being yellow we've got B over A plus B plus C squared. So we add those two things together and we should get 13 over 36. Okay, probably the first counter is red and the second counter is not red. So the first counter is red and the second is not red. Okay, so again these would be B over A plus B plus C, and then we've got C over A plus B plus C. Okay, now it's just thinking about how we lay this out. Here I've got this one times by this one and this one times by this one. So if we times them together, essentially I wrote them out like this in terms of squares before. I'm going to write them out a slightly different way. So A times B on the top, so that's AB over A plus B plus C squared, and this one is going to be AC over A plus B plus C squared. Okay. Right, now at this point we need to start putting some things together and making some equations. Probably that both counters are red or that both counters are yellow is 13 over 36. So A squared over this squared, B squared over this squared. So we've got A squared over A plus B plus C squared plus B squared over A plus B plus C squared is equal to 13 over 36. Go. So that gives us a squared plus b squared over a plus b plus c squared is equal to 13 over 36. Okay. We could try a few things at that point and try and do a bit of trial and error, although I wouldn't suggest it. The probability that the first counter is red and the second counter is not red is 1/4. Okay. So it's these two added together. So essentially we've got AB plus AC over A plus B plus C squared is equal to 1/4. Okay. Right. Now I can factorise out this numerator to A lots of B plus C. And then I can maybe start making some equations and start solving stuff here, hopefully. Okay. I'm going to rewrite these on the next page, these two things. So it says blank page, but obviously I would use more paper in an exam. I don't have more paper at the minute. So a squared plus b squared. A squared plus b squared over a plus b plus c all squared is equal to 13 over 36, and then we've got a b plus ac over a plus b plus c all squared is equal to 1/4. Right, with this one I'm going to factorise the top into a lots of b plus c over a plus b plus c squared is equal to 1/4. Now from here I'm going to multiply up by my denominator and put the 4 on the other side. So I'm going to get 4a b plus c is equal to a plus b plus c squared. Okay, and then from this one here again I'm going to multiply up through. So that's going to give me 36 lots of a squared plus b squared is equal to 13 lots of a plus b plus c squared. Right, so we've got the same denominators here. What I'm going to do is this is a plus b plus c squared. I'm going to take that and I'm going to put that into here. So I'm then going to get 36 a squared plus b squared is equal to 13 lots of 4a times by b plus c. And now we're starting to get something here which is a lot easier to work with, but we've still got some a's and b's and c's, which is not the nicest thing to see. So 36a squared plus 36b squared, 13 times by 4. Okay, let's expand this a little bit and see what we can do. 36 a squared plus 36b squared is equal to 13 times by 4, 52. AB plus 52 AC. What we need to do in some way is try and get rid of one of these variables. Well, ideally 2, so we've got something we can solve. Now we've got lots of things with a's in, but we've got one thing that doesn't have an a in, that's the b squared. Okay. I'm just going to go back quickly and have a look at the question. Okay, now maybe I'm doing too much or trying to do too much by actually working out all the probabilities here. The question just asks work out the probability that Seb takes a yellow counter. So maybe we don't need to work out everything you know, all the amounts. We just need to work out the property takes a yellow one. So, right. Okay, so if we think about this in a slightly different way, instead of trying to work out the exact amounts, the probability that both counters are red or that both counters are yellow. So, essentially, that is, I'll do it on this page so I can see what I'm doing. That's probability of red, red plus probability of yellow, yellow is 13 over 36. Okay, now the probability of red, first counter being red, and then yellow plus probability of red, blue is equal to that has got to be equal to 1/4. Right, so probability of red, yellow and red, blue is 1/4. Now the probability of red just in general is basically going to be the probability of red, red plus the probability of red, yellow plus probability of red, blue. Okay, so right, this might be getting us somewhere. Probability of red is going to be the probability of red, red plus 1/4. Okay. Now I can now go back down to here potentially and do, well, that's the probability of a red minus 1/4. Okay. So red minus 1/4. Let's take this down. Actually, I'll do it on the page. The probability of red, red. Red, red is probability of red minus 1/4. So you got probability of red minus 1/4. Probability of red minus 1/4 plus probability of yellow, yellow is equal to 13 over 36. Okay, right, let's add that quarter to both sides. So 13 over 36 add 1/4 is 11 over 18. So probability of red plus the probability of a yellow and then a yellow is equal to 11 over 18. Okay. Right, might be getting somewhere now, potentially. We've now got like another equation we can use. Probability of red and then yellow, yellow. So yellow, yellow. And we want to work out a probability that Seb takes a yellow counter. So just yellow. Now probability takes a yellow counter is yellow, red, plus yellow, yellow, plus yellow, blue. We don't know any of the other ones. Okay. Let's start by doing some stuff with this equation again and making another equation and seeing where that gets us. Essentially we just need to work out, well, A, B and C ideally would be good. Let's go back and have another go. Right, so probability of red is going to be just A over A plus B plus C plus probability of Y, or yellow, yellow, is going to be, let's just check this, B squared over A plus B plus C. squared is 11 over 18. Okay, right, I'll make this so it's focused better. Okay, now what we need to do is multiply through here by a plus b plus c squared. So we'll get a lots of a plus b plus c squared plus b squared is equal to 11 over 18. Sorry, that shouldn't have been squared, that first bit. A plus b plus c squared. Now we did have a plus b plus c squared is 4 lots, 4a times by b plus c. But that's putting in a c where we don't really want it. The problem is the squaring at the moment. It's proving to be a tricky question, this one, a very tricky one. Right. And I feel as though I'm overcomplicating it because it shouldn't be this difficult, I wouldn't imagine. Okay. Right, we've got 11 over 18 here, a plus b plus c all squared. So a plus b plus c squared up here. Let's have a look back at the question. Red counters, yellow counters and blue counters in a bag. Kevin takes at random a counter from the bag. So red, yellow, blue. Puts the counter back in the bag. So the denominator is still the same. The probability is still the same. Okay. Okay. Maybe I've overcomplicated this by doing a over a plus b plus c. Maybe I should use on x, y and z's. I'm going to try doing that without overcomplicating this. So x, y's and z's. So let's try again. X, Y, Z. X, Y, Z. One thing this will do is make it easier to see how to get rid of the variables if I need to. So this is red, red, yellow, blue, red, yellow, blue, red, yellow, blue. Okay, right. I feel as though because of the squared nature of this that they want us to do it with basically simultaneous equations with quadratics. So both red, both yellow. So that is x squared add y squared. So x squared add y squared is 13 over 36. Okay, right, so that's a lot more straightforward there. And then the next bit is probably that the first counter is red and the second counter is not red. So first is red, second is not red. So we've got x, y plus x, z is 1/4. Factorise the x's out. So y plus z is equal to 1/4. Right, Now I need to work out a way of getting an equation without 3 variables in it, so I can eliminate one of them. The other thing I'm thinking is this looks something very similar to, x plus y all squared. What would this give me? Let's think about that. X plus y squared would give me x squared plus 2xy plus y squared, which is not gonna, it's gonna be, so maybe this could help. Maybe this could help. So using that, x plus y all squared is x plus y squared minus 2xy is equal to 13 over 36. I've run out of space here. This is a problem. I'm running out of space now. Okay, it's getting very messy. Let's rewrite this down here. X plus y squared minus 2xy is equal to 13 over 36. Let's put the 2xy on this side and take away the 13 over 36. X plus y all squared minus 13 over 36 is equal to 2xy. Divide by 2 to get xy, which I can then put into here. I'm then going to get x and z. I can get z in terms of x, or x in terms of z maybe. Okay, I feel like I'm going to need a third equation no matter what I do. Xy is equal to a half x plus y squared minus 13 over 72. That's not going to help me, because if I just substitute it in, I'm still going to get x's and y's. Right, okay. Back to the question again. Okay, x's and y's definitely helped doing that. I could just look at the mark scheme, but I don't want to do that, obviously, and I shouldn't need to. Probability that both red counts and both count. Right, both are red, so red, red. Both are yellow, yellow, yellow. Okay, so I've got x squared, add y squared. This is the next bit. This is the problem that is going wrong. So the probability that the first counter is red and the second counter is not red is a quarter. That's that key bit of information which is introducing the Z, which I don't want. Where the first counter is red and the second is not red is 1/4. Okay. Going to use some more paper here. Right. X squared plus y squared is 13 over 36. That's what we've got so far. We've also got x, y plus x, z. So x times by getting the, so red, then a yellow, plus probability of getting a red, and then a, what was it? Was it blue? Blue gives us 1/4. Okay. Is there anything else we can get? I'm being silly, I think. The other equation is x plus y plus z is equal to 1. Okay. Right. Okay. I think I've been really silly with this. Never mind. Sometimes these things happen. So this is x lots of y plus z is equal to a quarter. Okay. You've always got this fact with probabilities because the probability of x plus y plus z has to equal to 1. They have to sum to 1. That was the third equation that I needed, that I kept thinking I needed another equation. That's what it is. So what will this give me? Well, I can work out y plus z. That is going to give me y plus z is 1 minus x. Okay, now hopefully this will give me something I can solve. So we'll put that into here. So we get x lots of 1 minus x is equal to 1 quarter. So we've got x minus x squared is equal to 1 quarter. Right, now put all of this onto the right hand side. 0 is x squared minus x plus a quarter. To make your life easier, times everything by 4 to make that into a 1 possibly, or just use a quadratic formula. I'm going to use quadratic formula here quickly. So x is equal to minus b, so minus negative 1 plus or minus the square root of b squared, so minus 1 squared minus 4 times by a times by c, which is a quarter, over 2 times by a. And so we get x is a half, or x is a half. So both of them are a half. So x is a half, okay? So the probability of it being a red is a half. Okay, so probability of red is a half. Now we're getting somewhere. Okay. Then I can substitute, of course, equation 1, equation 2. Substitute x equals a half into equation 1. And we get so I've put probability of red equals a quarter. That's wrong. Probability of x is equal to a half. The probability of r is equal to a half. Sub x equals into half into 1, so we get a half squared plus y squared is equal to 13 over 36. And we only need the probability of yellow anyway. So a half squared is a quarter. Quarter plus yellow squared is equal to 13 over 36. Take away my quarter from both sides. We're nearly done. Y squared is equal to 13 over 36 minus 1 quarter, which is 1 over 9. So y is equal to plus or minus a third, but probability can't be negative, so it's going to be a third. So probability of yellow is 1/3. Okay, there we go. That is why you make sure, if you're aiming for grade 9, if you are, and if it's attainable, obviously, if you're not at a grade, 7 or 8 yet, I wouldn't be aiming for a grade 9. But if you are aiming for a grade 9, you need to make sure there's, you've got about 10 to 15 minutes, as much time as possible to do the last question, because it could take a lot longer than you think. Okay, because they do like to put twists in there. They do like to make tricky questions at the end. So make sure you've got enough time so that if you are stuck, you can work your way through it. Okay, so probability of y, yellow, is 1/3, which, going back to the question, work out the probability that Seb takes a yellow counter, 1/3. Okay, there we go. Thank you for watching. and I hope that was useful. I think the key point to take away from that last question is don't give up even when things seem difficult. Think of different approaches. Think of actually the bit of information you need, and how could you get that? What is it that you're missing if you're struggling with something? Okay, and if you can work out what you're missing, then it's a case of actually trying to find that extra thing. Okay, if you've got 3 variables in simultaneous equations, then you need 3 equations to solve it. Okay, right, yes, thank you for watching. I hope that was good. Please like the video, if only for going through that last question and the struggle that took. Okay, see you in the next one. Bye bye.